So everybody can hear me? Kind of? Okay, awesome. Um, Today I'm very excited to present about uh, a workshop on building reproducible and scalable workflows using NextFlow. I know I presented this before. I see a lot of familiar faces, and I know some folks on my group uses NextFlow, and some folks on Isa's team uses Silk and SnakeMake. So don't worry, I also have I've been hearing things about challenges in the Isa's group too. I have some maybe some surprises for you guys. Maybe not maybe entirely convince you to um uh switch to NextFlow, even though I hope you guys do look at it, but at least look at maybe how NextFlow structures workflow, some like interesting architectural patterns. So even it will be worthwhile even if you use a different pipeline. So I'll like zoom through sort of the introductory section because I feel like everybody here perhaps is already like data pipelining experts, right? So um but very basic introduction. Why do we care about workflows? It's really namely we want to like focus on reproducibility, right? You write a bunch of bash scripts and 2 years later you have no idea what you did, or like maybe your computing environment changes, right? So to have a kind of a framework that like enforces you to archive and also reproduce your analysis is really critical. And second reason is portability. Not just like portability in terms of like say in your internal hardware, right? Like I know folks have been talking about how even on Oscar we're doing an upgrade from Red Hat, whatever the older version, to RHEL9, right? So we want to make sure that with any kind of hardware changes, we can still run our workflows. And even like let's say you have collaborators beyond Brown, or you want to open source your uh, uh, pipeline to even the cloud so other people can run it, but you don't want to actually manage it, right? Know that you can just give them like your package and they can go run with it, like spawn it an instance in AWS or Google Cloud Platform, whatever have you. So yeah, those are kind of the two things, and I'll try to communicate how NextFlow sort of wraps everything up. And kind of the format of this workshop is I will do some very simple examples, like starting from Hello World. But what I want to first show is kind of like once we finish everything, I will actually show how we go from Hello World to a real live kind of production workflow, RNA-seq workflow in our comp bio group, right? And you don't have to even know what this flowchart is or care about what this flowchart is. But basically, this is just to show that kind of our use case in comp bio core group is where a common workflow we have a RNA-seq. We need to run a lot of RNA-seq analysis. So calling attention to the left-hand side, right? We have like lots of samples. So like maybe you guys have seen this too, where you need to have like a sample sheet, right? Where you need to put in like all the inputs that you want to run and maybe some metadata associated with that series of inputs. And then on the right side is the actual sort of tons of steps that the inputs need to go through the pipeline, right? Imagine, right, these are the individual bash scripts that get run on Slurm. And really the takeaway here is right, for some of them, right, like one job might depend on another job, right? So for instance, like the Q, where my mouse is, the QC reads and the contamination screen is dependent on the first step of the workflow when we need to trim the reads, right? So kind of like how does the scheduler figure out the dependency, and like as soon as one job is done, be able to run the dependent jobs downstream. And also there are certain points in your workflow where instead of just like, kind of waiting for, say individual jobs to run, you want to like wait for a batch of jobs to run, right? So this is where this third step comes in, the multi-QC, so which stands for like, if you imagine, right, like we want to wait for all of the samples in our, aggregate sample sheet to finish running from like the previous steps, and then we want to, like submit all of them for like kind of a quality control for the whole batch. So this is kind of like where the the flow comes in, right? So like you define the flow as in like, individual dependent steps, but also you might have some kind of scatter gather pattern, if you will, right? Where you want to scatter all your steps, but at the end, when all the scatter steps finish, you kind of want to get to the gather step, right? Where you're trying to summarize a report for all the things that has finished. So this next section, before I get straight to like, the actual workshop part, is just a simple compare and contrast, right? This is a naive approach, right? Where you're just writing all these bunch of disparate bash scripts, and none of it is like, containerized, right? You have the conda environments, and as just scrolling, right, as your pipeline becomes more and more complicated and you have more parameters, more like edge cases, more conditionals, it gets harder to maintain, right? So yep. So so now I'll jump right into the actually like, running NextFlow. So I don't know if folks want to sort of like follow in the workshop format. So if you do, then I'll do it on my screen. So the first thing that we want to do is git clone this oops is git clone 2 repos. So one is oh right, so let me give you guys the my notebook. Sorry, I should have done that first. So you guys can copy and paste. Is it Oscar? Oh, DSCoV, yeah. I'll paste in the DSCoV channel. So if you guys get to step 1, the setup, right? Step 1A, set up NextFlow configuration script. So if and no worries if you don't want to set it up, because I can just follow along on my screen, right? So I literally just yeah.
The background
Settings. Yes, also. Okay. Oh, right. Yeah. This is better, right?
Maybe black on white or white on that.
Okay. Yeah, I realize a projection is harder to see. Oh. All right, and then apply. Okay, yeah. So basically the first step I did is just git clone on this github.com comp bio core / workflows _on _oscar.git. And there's another project that's the repo for this workshop. And so if you want to get clone this one, and all of it is in the step 1A of that notebook in the Slack. So I'm not gonna clone it because it already exists in mine. And for the step B, we just want to install NextFlow. So if we go over to the notebook and for step 1B, if you guys can copy this command, the bash workflows on Oscar install me install.sh. And for the prompt, I'm gonna just enter NextFlow, right? And it's gonna ask me for my GitHub username, so I'm gonna enter it. And it's gonna ask me for my GitHub token. So for this step, it takes a while, right? Because you have to set up a new token, but actually it's not necessary for this workshop. It's only necessary if you want to like do some commits right via this. So I'm just gonna press enter. And it's gonna ask me if I want to change the default resources for my NextFlow pipeline, and I'm gonna say no. And then that's it.
An error that says no such file in the record looking to install that SH file.
Oh, I in my command, if you see how I have a CD tilde, so I made it so that I think I just have it installed in your home directory, but it should be whatever you git clone that directory. So instead of that bash tilde, right, if you just remove the tilde slash, maybe that should work. Oh,
It seems the install.sh script supposes that you cloned the directory to your home.
I see.
Modify the line where it says
Okay.
Python 3, whatever.
Okay.
Yeah, so
Okay, so actually, yeah, the CD tilde slash then is essential. Okay.
yes.
Yeah, they want to move it. But on board with that one. Yeah.
Okay, awesome.
It needs to be default be on the home directory.
Yeah.
Installing it in your bash directory.
Yeah. Okay, if everybody kind of has it set up, or no worries if you guys are still running in trouble, because I have everything outlined in this notebook, so all the outputs, so you guys can follow along and then try to install it later. But I guess I'll try to move on to the actual the fun part of the workshop, which is actually like working through all the examples, right, and getting to a full-fledged workflow. So what is a tutorial without like a hello world example, right? So basically it's already, when you git clone this workflows workshop directory, it's already in the repo you clone, so no worries about copying this text. But I'll just kind of talk through this. So you guys can see it's pretty straightforward, right? So like here we have one single task, excuse me, one workflow existing only one single task, right? Say hello, right? And you have up top here like the parens.name is just default world, right? So, and in the really the thing is echo, right? And so if you guys want to follow along and actually run it, what you can do is once you clone that directory, I'll clear mine. If you cd into workflows workshop where you cloned it, and now if you just do NextFlow run hello world, and I'll run it. So, and you can see on my screen, it's running it, and but what's actually happening behind the scenes, right? So, just hello world example, but you guys can see where it says executor slurm. So it's actually not running locally on this open demand instance, right? It's actually executing via slurm, a job that's saying hello. So okay, and it's done, right? And it says hello world. But maybe that's not the interesting part. The interesting part is if we go into say the if we look into the NextFlow working directory, which keeps record of what just ran, so you can see that it actually generates a automated SBatch script right here, right? Where it says say hello, and it gives like that default, CPU memory allocation, and it gives you a standard out error, right? So and if you guys ran it, so it should be in your NextFlow should have created a new directory called cd work, and all that information should be there, right? So I went to my cd work, and then I just listed like the most recent directory created. So if we look at the command.sh, you see it says hello world, and if I do the command dot trace, right, that should tell me on slurm, right, the percent CPU usage and the peak memory and all that information. So this is kind of like for your debugging or benchmarking. And if we go to the command run, this will tell you the actual, right? If we scroll all the way to the top here, if you bear with me, right? So here's where the highlighting where my mouse is, where the SBatch is automatically generated. So pretty straightforward example, right? The other example, which I will not run, but it's basically saying hello world, but I can give it a custom parameter, right? So where my mouse is highlighted, where I say dash name Bluno Bear, right? And it will then, instead of taking the default parameter world, it will take Bluno Bear, right, where the task has a parameter val name, right? It will say echo hello Bluno Bear, right? So again, pretty straightforward example. Apologies for this screen black text, but so okay. So now we've done like the simple hello world example. Obviously, that's like still a far cry from like our real world implementation of the data pipeline, right? Because the data pipeline, as the name implies, it just doesn't consist of one task, right? Usually at minimum it has to be 2 tasks. And like really the whole point is that we want to like take whatever is the output from the first task into the input of the second task, right? So here's where I want to show you guys a sort of that 2-step workflow. So I think I'll just have you guys run it, right? So it's a count words example, right? So if you guys want to go to your that your workflows _ workshop / workflows directory and run NextFlow run count words.nf -- name Bluno Bear or whatever have you. It's you know, this basically the command in 3B step 3B of the notebook, and I'm just gonna press enter here. And while that's running, so you guys can see now there's at the bottom that projector, right? It says now say hello and count words, right? So what exactly is going on there? So while the Slurm thing is running, I'll just actually go do the word count example, right? So first thing is that we still have that say hello, right? No surprise here. But what we're doing is see how we're instead of echoing to standard out, we're saving it to like a hello.txt, right? And that is defined in the NextFlow process block for that job as an output where it's hard coded as, you know, hello.txt. So basically we're saying, you know, we know that the output for say hello now is this file hello.txt, right? So and then when we get to our second task in this workflow count words, see how we have an input called path file in, and pretty straightforward, right? We're literally just doing a wc-w for this input file and then printing out to our standard out, like, you know, how many words there are in the input file, right? So you can see basically the takeaway here is right, so in NextFlow you can basically chain these tasks together, right? So the say hello will emit a single output, which we call, you know, this hello.txt, and that feeds into the count words as an input file. And this is a very simple example, but you can imagine, right, like in your upstream task, right, in your output, you can define as many arbitrary outputs as possible, right? Whether that be files, you know, integers, strings, whatever have you, right? And you can like, you know, kind of do your parsing of any of these multiple output files, or parsing of the of these like metadata associated with, you know, each of these subtasks, and then in your it will all kind of get defined into as inputs into you know, any of your downstream tasks. This is kind of, and from this simple example, I really want to stress it's kind of one of the key differences between NextFlow and say something, if I understand it correctly, Soak, where everything gets run like as working directories, if you will, right? So like, you know, step A, all the steps share a common working directory, and kind of like each step you're like working through, you know, the same working directory, and just like making new additions or like parsing files that's already worked on this working directory. And you know, it seems like a cosmetic difference, but you can imagine, you know, here you can kind of define really complicated workflow where, say, you know, the downstream task depends on a bunch of inputs from, you know, and certain upstream tasks, and it will like you know, figure out the dependency the most efficiently way to like, you know, launch a job as soon as all the necessary inputs for, you know, a downstream task is done, finished by an upstream task. Oh, yeah.
I may have missed, but my question is related to that in like makefile kind of terms. How much logic do you have to specify on those dependencies? Like if a job gets killed and you want to rerun it somewhere in the middle, how much does NextFlow automatically just say, oh, I can see the output of this, therefore I won't rerun it, versus you have to tell it?
Right, that's an excellent question. So the answer is yes, NextFlow will keep track of all that dependencies. So by that I mean you can run a command called NextFlow, right? Like run whatever the thing and then dash resume. And what it will do behind the scenes, it will check to say, oh, okay, have I run this task before, right? Because you know, you have this process, you have your actual shell script, and you have the input files, right? That you're specifying with all your subtasks and your input files. You know how you have your MD5 hash. So it will check to say first, are all the commands identical with like a past run that I have done? And are all the inputs for this script, like the input files, MD5 hashes are identical? If so, then reuse this past run as, you know, the outputs of this past run as inputs for whatever, you know, the step hasn't been run before.
If I can follow up, so
Yeah.
to be really concrete in this example, if hello.text exists where it's supposed to exist, well, I have to use the resume flag, but otherwise the next will just skip, say hello. It doesn't actually run that process, but it says the output exists or something else.
Yeah, no, that's another great question. So if I can sort of go to my command line. So I think maybe is your question like if like hello.txt needs to exist somewhere, and like maybe you're worried about like collisions if like, you know, it's already existing. I don't know. Okay.
I'm really thinking of it from the standpoint of like, for very complicated processes, you're often running through lots of files, and it often happens things die.
Right.
So I'm just asking, like, how much work do I have to do to figure out where it died and rerun it versus, and that's what I was kind of referencing about sort of. It actually will check dates even and be like, oh, if this output is newer than that input, I'll know that I have to redo something, and if not.
Yeah, so NextFlow will actually not check based on the output. It checks on two things, if I recall. I think one is that the other previous, that the commands haven't changed somehow.
Yeah.
Workflow itself. And then two, yeah, obviously the job is completed successfully, then it will just say this job is done, the commands can change. I'm going to skip all the steps and then start resuming from where you are. The main thing usually happens for me, my workflow is where I run out of memory for say one job, and then I'll go through and start it down from only that job that failed because of memory. But you have to use the resume flag. You don't use the resume flag, it's stuff.
Okay. No, awesome. That's a great question. So if you guys ran the workflow, you see, or just see on my screen, right? So basically does it say hello count words, right? So I put in the blue note bear, so it's 3 words, right? So echo out the 3 words, and then it will actually count the words, which is 3, right? So yeah, so that's the example for sort of the very basic 2-step workflow, right? So okay, so kind of the next example I have is still on this count words example, but this is where, you know how you guys notice everything we have been doing has just been like echoing to the standard out. Of course, like in a real life data pipeline, we obviously don't want everything just to kind of like be sort of like in this ether of standard out, right? So we actually at some point need to like, if you will, at the end of any pipeline, have kind of a handoff step, right? Any kind of analysis where we're saying, okay, we want to organize our final results in some kind of like coherent manner, like, so that when the pipeline's finished, like, the first thing is you want to actually like click on a folder and see like, whatever your final report, your PDF, HTML, right? So basically calling attention to this workflow, it really the only thing that's changed from the previous example is where my mouse is highlighted, the publish dir. So this is basically saying that like while we're running this count words step, save whatever it is in this execution directory into kind of our final output directory, right? So, and you can give it like another pattern. I just say like save this everything in this output directory, but it follows that Unix glob pattern. So you can give it like /star.txt or star dot whatever have you, right? If we run it, and I will save for interest time, I won't run it, but see how here I give it a out dir words dot underscore out, and it will give us the same output, but what it will do is in our specified output directory words.out, it will then have a final like report, if you will, for our simple example count underscore words.txt as is defined here, right? Excuse me, defined here, right? And it basically will say 3, right? So this is just a simple example how you can actually, save things to a handoff directory. Okay. So now moving on to step 4 of the notebook. And here where I think is where things get interesting, right? So I think, and this is having to do with conditional logic. So, sounds wordy, but what do I mean by that? So like, I'm sure you guys have run into this issue with workflows or pipelines, is where, you write like a sort of like a simple pipeline from the start, but eventually, like whether your collaborators or, as you're like doing things like more edge cases gets piled on, right? So let's say, you're like, okay, if I need to run this special analysis, I need to add this flag so that it needs to like tack on one more step at the end or some steps in the middle, or I need to add another flag to say like, okay, pass this parameter only if this conditional flag gets, passed on, and so on and so forth. So this is what and then, normally what I do is I just then have like, data pipeline underscore, v1 or underscore this conditional. So it just like, makes all these duplicates. And what I want to communicate here in this example is I want to implement on top of that count words example where I give it 2 conditional flags. One is where I reverse the words, right? Instead of hello world, it would be like, hello world reversed if I pass in this conditional. And also instead of counting words, if I pass in count letters, it will, count the letters instead of the words. So for the reverse, it's pretty straightforward, right? So I put in a new parameter called params that reverse equals here, and I basically say if this reverse is true, then I put in a new function called reverse, right, to say hello. And similarly for count letters function, basically I put in a if block in the specific task process count to say, okay, if it's count letters, I do WC-M, and if the count letters flag is false, I do WC-W, right? And here's the full workflow here. But uh, Additional, yeah, so if we run, I mean, here's the output, but I'll just run one so we can see it. Oops. Gotta go here because that was the top. And you can see because I put in just reverse, right? So instead of those two steps, now I have a tacked on a reverse step in the middle, say hello, reverse count, right? But it's pretty straightforward example. So I'll just fast forward and kill the suspense, and I'll put these two right where the hello world is reversed. And well, that's funny. I'll cue this up. Okay, so I think Slurm is like beyond usually slow for me today, but again, I'll just kill the suspense and say if I add in the count letters, right? So you guys can see it's still reversed because I have that dash dash reverse on, but once I count the letters, it gives me 13 instead of say 2 words, right? Hello for hello world. And again, it's because in my count block, I'm doing this if statement where I'm doing a switch, right? Instead of WC-W, I do WC-M. So pretty straightforward stuff. But you guys can see how you can make really complicated workflows now where you can have like multiple alternative branching in your workflow, right? So it's not like you can have a static number of steps, and based on your if statements, you can say, okay, run this step only if I have this flag turned on, or if this output file exists, or if the length of this output file is a certain size, et cetera, right? Okay, so now if I go to step 5, which is having to do with parsing a sample sheet. So what do I mean by that? So, we've gone through like, how to chain steps together, how to do like conditional logic. Another big thing dealing with data pipelines, right, is where you obviously have to define your inputs in the very beginning of your data pipeline. And sometimes that could get very unwieldy, right? Because you could have like, literally hundreds or even thousands of samples. And it's not just the actual inputs, right? You might also want to carry certain metadata associated with that input, right? So in my very toy example, I define like, say I want to count words in certain documents, certain set of files, right? So I have like hello1.txt, hello2.txt. But for my metadata, right, it's kind of that flag we talked about, whether we want to count words or count letters, right? So see how I have to count underscore letters in my little TSV file where it says if it's false and I count the words. But for the second entry, in my sample sheet, hello2.txt, I want to pass in that count letters, right? So so basically, if I scroll down here, if I highlight this line here, so this just simply communicates how NextFlow creates in from this TSV file, right here where my mouse is, it parses the CSV headers and it creates like a channel, but that's just like NextFlow speak for like an array, if you will, of jobs, right? So in this case, we want to create kind of like two array of two kind of like spawn two sub workflows, right? One is for hello1.txt, hello2.txt, right? And basically I'm saying, once I create this channel consisting of hello1, hello2, now I actually launch this count document kind of series of steps on this channel. And sort of count document is like already kind of what we've seen before, right? Where we kind of like actually count the documents, but we check to see if the metadata that we carried in, right? So really what we care about is, right, the path of the document that we're counting, and if we're counting by letters or words, right? So that's where this tuple is, right? Because now imagine we're actually parsing that TSV file, right? Or CSV TSV file where it consists of this entry, right? Where it's a tuple of the file path and also whether we want to count by letters, right? And you can see pretty straightforward, right? We do that switch of WC-M, WC-W, and that's it. So this is a whole workflow, but if I run it here, and I guess the one thing that's interesting is if you guys notice here, it's very subtle, but see how now all of a sudden the count document is 0 of 2, right? So that is saying that we are not just counting one document, because we're giving it that sample sheet of hello1, hello2, right? So it's actually executing both count document process in parallel. And this would be more obvious if we say like submit 100 documents, right? So you will see like live, like saying, okay, say 40 of these count document is done. Now we're moving those 40 are moved to the next step in the pipeline, right? So you can see how it tries to schedule and figures out the dependency on the fly of which things to count. And again, you can see, document 1 writes saying using letters, and document 2 is using words. That's why the letters and words are different. Okay, so so we went through sort of like how to deal with the sample sheet. Now then the next step is having to do with scatter gather pattern. So what do I mean by that is like we kind of already did a scatter here, right, in the sample sheet. So meaning that like we have a sample sheet of two documents, right? hello1.txt, hello2.txt, right? But you can imagine in a real life example whether you're like doing some kind of splitting, like a bunch of DNA reads and you're analyzing them, but once everything is done you need to like aggregate all the results, or basically like the scatter gather or map reduce, right? So like at some point once you split the things, you need to then like also actually aggregate and like summarize all the results together. So this is that quick example. So basically what I did on top of that count word example is I added that gather step where I say, okay, flipping back to this screen. So see how I have, count me using letters, count me using words. I say, okay, I have 24 here and 4 here, but what if I just want to sum everything together, right? Sum all results. So basically it's saying, my input here is, see, notice how the subtle difference, instead of path file, it's files. So I'm saying, give me all the counts from all the upstream tasks that previously I was counting the words, right? Whether by counting by letters or words, excuse me. And now do some like awk magic to, sum up all those numbers together, right? So pretty straightforward example. So yeah, so you guys can see I basically have that sample sheet still here, but now I basically save all my results for my from all these scattered word counts or letter counts into this count results, and basically this is a placeholder for all the counts, right? And then that goes into this gather step, sum all results. So I'll save everybody the suspense, but basically once I run it, it will still do the counting of the documents, but at the end it will also sum all the results, right? And it will give me 24 plus 4 is 28. But this is again just a toy example for how you implement that scatter gather. So okay, so that is really everything I really want to communicate. Is just like taking you guys through just like all the basic, and really like I want to say like everything that you kind of need to like really implement the workflow in NextFlow, right? And what I want to show is kind of this real life example now of RNA-seq pipeline. And it's okay if like you don't care about RNA-seq or even care to understand it, but what I really want to kind of scroll next is kind of like how everything we went over applies even to this real production pipeline that we're using. So for instance, pattern 1 that we use is a conditional logic, right? So you guys can see right off the bat here, right? So in our RNA-seq pipeline, sometimes we don't have a index for the reference genome. You can think of it as just an optional file that we need, a necessary file that we need to have. And if the user doesn't specify this reference genome, excuse me, if the user doesn't specify the reference genome index, then we say, okay, then we have to kind of like inject in this pipeline to build the index on the fly, right? So this is kind of that conditional logic, having a conditional step in your workflow. And the second pattern is we have this sample sheet, right, that we just went over with the word count. But in our real life RNA-seq example, the sample sheet is like the sample name and also like the DNA reads associated with that sample, right? So that's kind of like our metadata that we're carrying throughout this pipeline. Lastly is that scatter gather pattern that we talked about, right? So this is in our toy example where we counted the words and letters, right? 24 plus 4 equals 28. But in our real life RNA-seq example, what we do is we run a series of steps, right? So like we do individual FastQC on the individual samples reads, we do genome alignment on the individual samples, but at the end of it all, we need to like kind of make a report, right? A final quality control report, if you will, based on all these disparate jobs. So kind of like a visualization for our users, right? To like sanity check to see like, did this run work? Is the data quality very good? So, you can see we chain all these steps together, but at the end, we say, okay, run this final multi-QC, which, short for multiple quality control, and it will take in, output files from FastQC, another one called FastQC screen, quality map, HTC count. But the takeaway here is that like, we're defining all these jobs and how they flow, and then sort of like at the end, sort of like, how we do this gather step, right, according to NextFlow. Yeah, and that's kind of everything I wanted to present today, but I do have one or two bonus things, and it's based off of for ESA's team, based on what I've heard people care about or the challenges that on ESA's team have faced. So the first thing was Tim mentioned for Silk, you guys have an issue where, not an issue, but just like where you're trying to query an API and it needs a token, and how do you actually like keep this token kind of secret, if you will, right? Because like the data pipeline sometimes logs these tokens to your standard out, or like each individual users might have like their own individual token. How do you manage that? So the way NextFlow does it is actually they have a NextFlow secrets, where you imagine in your pipeline, you kind of like define what the secret is. Before you run the NextFlow pipeline for each individual user, you can set what that secret variable is, right? So in this case, I'm in this example, I'm running kind of a weather .gov alert for Rhode Island. So my secret location is RI, but you can imagine it could be your API key or whatever have you. And so when you run it, it will like run it as is, but the key takeaway is that it will not expose that API token or your secret or your SSH key, whatever have you, in the standard out log or the execution directory. The other thing I wanted to show was I think Tim also mentioned for Silk or other pipelines, how do you dynamically size memory and CPU specification for jobs? And the way we do it in NextFlow is like we can set a variable for like say once you produce an output, we say, okay, what is the file size for this output, right? So this is where my mouse is saying like stat hello.txt, right? So this is like the output I'm making, and I save it as a variable, right? So say like this hello.txt file is only like whatever, like 500 bytes. So in my subsequent step for the memory spec, I give it to Slurm, I can pass that along to say, okay, if I want to load this file into memory, this is how long it's going to be. And you can do like even arithmetic on it, right? Like times 3 divided by however, and the same thing for CPU. So you can really like dynamically size your, you know, how much memory and CPU allocation you want for it to Slurm. And yeah, that's it. Yep, go ahead.
Yeah, so two quick questions. I gotta run to class.
Oh yeah.
How do you recommend like going about testing with NextFlow? Because like you can't test like individual parts. And also, if you already have like a pipeline set up with like multiple bash scripts, do you think it's feasible to use NextFlow as just kind of like a package to kind of run those things?
So for your first question, I do see the challenge. What I would do is you know, like have say test inputs, if you will. That's like, you know, very small, but you know how NextFlow at the end, maybe your pipeline generates your final report, and then you can go into that final report and you can say like, you know, assert, you know, in this final report that these files actually exist, and you know, if you have some metrics in those output files, like assert, you know, the metrics are what I expect. And I think, sorry if you can repeat your second question.
Second question was, I already have like a pipeline for like a taxi.
Okay, cool.
But I want to use like NextFlow to kind of run steps sequentially. Do you think that's like a good use of it, like to use it to kind of process the logic of processing the data?
Yeah, so for sequential, it's really straightforward. So like kind of like the hello world example, where it's just I'm scrolling. So sequential is really easy, right? So you can just say, you know, pass in the inputs from one job to the next, right? So you literally can just chain them, right? Count words, say hello, whatever. And all you have to do is just say, you know, right, whatever output I have here is in input as input for the downstream tasks. So it's pretty straightforward. And you can all of this is in that repo, so you can just, you know, follow that example. Once you implement the first, 1, 2 steps, the rest should, follow, so. Well, thank you. Okay, all right, well, thanks guys for sticking around listening, yeah.